Okay, go ahead.
Like I can remember that the gram-positive basic, gram-negative is acidic, and then it's certain type of strains, and you want us to know the rise of the bacteria of it. Like,
Rewind. All the way. Okay. So, gram-positive, gram-negative. It's a result in a staining procedure.
oh, I was thinking.
Right?
More in depth.
And that relates to what structure for the bacteria? The peptidoglycan that makes up the cell wall. Right? And so, remember, when we say gram-positive or gram-negative, we're not talking about charges. We're talking about a result. Did it stay what color for gram-positive? Purple. What color for gram-negative? Pink. Okay? Good. All right. Did I go over this picture last time? Okay. I'll come back to it. I want to go step by step through this one. Okay. So we watched that animation, that other website, right? And then there's another animation I had posted for you guys. The textbook put together. It's a really good one too. So, you know, watch as many as you need to, talk through as much as you can. I saw going through the discussion board, the introduction discussion board, a lot of you guys trying to hook up study groups and stuff like that. So I'm actually thinking I'm going to probably put together a discussion board for you guys today for just you guys to use to communicate with each other. So I'll name it study groups, right? And you guys can try and pair up and work together. I definitely want to encourage that type of behavior. It's really good for, you know, it's one of the best ways to learn for some people. When I was in college, I was always in study groups, you know, whether it be just me and one other person or me and a group of people. And the math one I was in, my friends are like, why do you do that one, Erica? You spend your whole time teaching them how to do calculus. Like, well, one, the guy is really cute. Okay. All right, that's okay, right? But two, if I could tell them, I know it. Right? If you can explain it to someone else and they understand and get what you're saying, you know it. Right? Probably the best way to learn is to be a teacher. Right? I didn't get all the blood vessels in AMP2 lab until I taught it for 5 years. Right? It takes a while for some of that tough stuff, right? Yeah, and having to explain it to people over and over again, for some of us, that's what puts it in the long term, right? So if you know that works for you, definitely get in a study group, right? If you can only handle one-on-one, that's still a study group, y'all, right? Because that's really good supportive. You know, one of my best friends, even to this day, my sister married her brother, so yeah, I'm stuck with her from college. We studied physics together. You know, she'd start doing the problem all the time. I'm like, where's your drawing? She's like, what do you mean? I said, you got to draw it out first. How can you just start doing the problem without drawing it out first? You know, and so, you know, I kind of would help her with that. And then when I would get kind of jammed up, you know, she'd help me, and we complemented each other really well. So, you know, you got to find your good complement, you know, and obviously not hang out with the people that don't complement you well. And don't take an offense to that, right? If somebody says this group isn't working for me, it's just not working for them, right? And that's okay too, right? You got to find what works for you, right? And go with it. And starting early is important, right? As we go through this material, you gotta do it as often, right, as possible. I kid you not, I walked around campus with flashcards. You know, it was before fancy cell phones. I still had those flashcards up until not too long ago, okay? I finally got to throw away the blood vessels. I finally know it. Right. I kept my amino acids because I still don't know those, but I don't have to. Right. But I spent a lot of time drawing those flashcards. I'm attached. Right. And that's the other thing. Whatever's worked for you in the past, if you've got to write out your notes, you got to make flashcards, right? Like I said, you got to go teach somebody else, then make sure you're doing that, right? Because the general consensus I got from this, and who wouldn't want an A, right, is you guys want to rock this class. But it's going to take work. Right? This is a 200 level course. This is not a walk in the park. Right? Even for me, when I was in your shoes, it was not a walk in the park. Okay? Make sense? Okay. So I'm here to support you guys too. And you know, if those study groups end up being in the study lab, when I have office hours and you guys have a question, send me a quick text. Ms. Erica, we're in the study lab. We're stuck on something. I'll run right over. Okay? You can include me. All right? But I got news for you. I won't tell you the answer. I'll probably ask you like 3 questions to get you there. But that's what a good teacher does. Right? They don't tell you the answer. All right, so let's work through this. So let's start with gram positive, right? Here's our steps off to the side, right, which you do need to know, right? Crystal violet, the primary stain, right? What do you see in this picture? The different shapes, right, and they're all purple because crystal violet is a purple stain. And where is the purple? Inside the cell, because we know what charge do cells have? A negative charge. What charge does crystal violet or a basic stain have?
Positive.
Positive. What do we know about opposites? They attract. So that's why the inside is stained, right? Because we're dealing with crystal violet, a basic positively charged stain, and a negatively charged cell. So it goes in. And this happens for all the cells in the picture, right? Everything gets stained. I abbreviated crystal violet, CV. In an English class, I get nabbed because the first CV I did not spell out right next to it. Okay, next step is iodine. So what happens when we add iodine? Do we see any color change here? No, everything's still purple. Where did the iodine go? Inside the cell. Is that it? Just went inside, that's it? Chilling?
I think it's mixing along with the other dye.
It's mixing with the iodine? Iodine and crystal violet bind with each other, right? It actually creates a complex, right? So it's not just crystal violet by itself, it's now crystal violet and iodine stuck together to form what we call a di-iodine complex. The dye, of course, being the crystal violet. Then the important take-home here is that this is a larger molecule now, right? It isn't just crystal violet, it's crystal violet and iodine. It's bigger. Okay, decolorization. Now we're talking about gram-positive cells, right? Right now. So what happens when we decolorize them? Well, what color are they going to be? No, gram-positive. It's going to be the purple ones we see here are gram-positives. Why do they stay purple? We're decolorizing. We're using alcohol. Why do they not get washed out in the back? It's thicker. The peptide layer of the cell wall is thick. But how does it react to the ethanol, to the alcohol? It shrinks. It shrinks. It shrinks. So when it shrinks, what does it trap inside that cell? The color, the crystal violet and iodine, that large molecule. So the last step is staining with safranin. So are they going to change color?
Not all of them.
No. They're purple, right? If you stain them with a red stain, are you going to see that you stain them with a red stain? No. Purple is a much more vibrant color than the red. That's why we do it in the order we do, because these guys will get stained with the red, but the purple is much brighter, so they just become a darker purple, not well represented in this picture here. So did I give you guys my laundry analogy yet? No? Okay. So when I was a kid, you know, every teenager at one point, you're in charge of laundry. I had a pretty large family, so we literally had color piles, right? I put all the whites in and accidentally picked up a red sock. My dad had pink underwear for a little while. He was cool with it. He didn't have to do laundry. So, my husband, don't tell anybody now, right? I love him because he wears black underwear. No issue there. I can throw whatever color I want in the laundry. If it bleeds, you're not going to tell, are you? Right? You're going to not notice if red or purple, right? The only problem is that black over time fades and they actually become kind of gray. Right? But you're not going to notice if that bleeding happens. It's when you have light colors, like white, right? Those god-awful tidy whities, right? If you put some other color in there and it bleeds, that's going to pick it up. But think about this again, right? This is the black underwear, the purple, right? Doesn't matter if they get stained with red. You're not going to notice. With me? Laundry always makes sense. Even for the guys, right? Sometimes we learn these things the hard way. My son once left a crayon in his pocket.
Oh no.
Those are fine until you get to the dryer. Yeah, not fun. At one point I thought about sewing his pocket shut. All right, so that's gram-positive, right? But obviously we get a different result for gram-negative, right? And again, this is not purple. This something happens, right? They change color. So in the first step, though, it's all the same, right? They get stained purple because it's a basic dye. It's positively charged, goes in the cell. I keep clicking the wrong mouse. When the iodine goes in, does it bind with the crystal violet? Sure, right? Yeah, and so again, the cells are purple. The difference in the differential step in this differential stain is the decolorization step. This is where we get differences, right? So when we decolorize in this case, we have a structural difference between gram-positive and gram-negative cell walls, right? If you were to compare them, someone said that gram-positive had a very thick layer. What about gram-negative for peptidoglycan? Thin, if they have it at all. But what's a key characteristic that most gram-negatives have? The lipopolysaccharide, which is a component in their what membrane? Outer membrane. That outer membrane. And what happens to that outer membrane when we hit it with ethanol? It washes away. It dissolves. And then, if they've got that thin layer peptidoglycan, is that enough to shrink and hold in?
No.
No. So these guys get decolorized. So if you were to stop here, would you see them under the microscope? No, they'd be clear, they'd be colorless, translucent. You can't see them. Do we want to be able to see them?
Yes.
Of course. So what do we got to do to see them?
Saffron?
We got to stain them, right? And that's saffron, right? Which is a red dye. But remember, we damage these cells. So they don't hold on to a lot of the red dye. They end up looking, what? Pink. And again, another basic dye. Saffronin is positively charged, attracted to the negative components in the cell, goes inside the cell. So this is, I don't have one of these anymore. This is it side by side, right? So this is where it differs, right? I don't have one of these toys anymore, but I did have one when I was a kid. And I've also babysat kiddos that have this. So some of you guys have probably seen this toy, right?
Yes.
Oh, yeah. Or played with it yourself. So those blocks inside barely fit into those different shaped openings in this toy. And what happens is little kids don't know. Notice there's two halves here. And there's actually a handle at the top and the bottom so you can pull apart the two halves and all the blocks fall out so you can do it all over again, right? Which is what kids like to do and even people, right? We're repetitious, okay? The only problem is if the little kid doesn't know that, how do they try to get the block out? They stick their little hand in that hole. When they do that and grab the block, now you have a hand and a block trying to get out a hole that the block itself barely fit in. So now you have a screaming little kid because they can't get their hand out, right? The block and the hand combined, too much, too big, it's not going to fit out that hole. You got to convince them to let go of the block, slide their cute little hand back out, and then you teach them how to open it, right? But word to the wise, teach them how to open it first, right? So you don't have to deal with the screaming kid with his hand inside the ball, right? But this is very much like the gram stain, is it not? Crystal violet goes in the block. Iodine goes in your hand. The two combine, and then they're big, and they can't get out. But what happens in the gram stain? One more thing happens, right? So block goes in, hand goes in. What happens to that hole? It shrinks. Can you imagine that? Wow, you'd really have a screaming kid. Right? But can you guys visualize that? Right? How two things together are much larger, right? Create a problem, especially with this toy. So here's your intelligence quiz for the day. Can you handle it? You're awake enough? How do you get that ball out? The top hole.
I say either take the rods out of the ball or the top cover.
Right. The rod's out of the ball. Right? Clearly, they had to put the ball in and then the rods because they stick out, right? There's no way you're getting it through the hole. Again, same principle, right? Two things together can get stuck. You got to separate them to get them out. And that's what we're doing with the gram stain. That's why every step is important, right? You can't skip the iodine step, right? We need it to be bigger and get trapped. You can't skip the decolorization step because then you're not going to end up with two different colors. And you got to do crystal violet before you can do saffron because if you did it in the other order, what would happen if you did it in the other order? What if you started out with red? Yeah, everything would be purple. The only difference is that the ones that are gram positive would get stained red and purple. So they would actually be a darker purple. I've done this on purpose just to see how it would come out. But can you imagine under the microscope trying to figure out if it's light purple or dark purple? I'm telling you, pink and purple is hard enough. Never mind light and dark purple, right? So the colors, right, use the order, everything has to be done correctly to get accurate results. So typically, too, when we're dealing with an unknown organism, side by side on the same slide, you'll do a known gram positive and a gram negative so that you know that you perform the test correctly and in the correct order if your controls come out as expected. If your controls don't come out as expected, you can't trust your unknown result, right? Just like pregnancy tests. They all have a built-in positive control. If that doesn't work, it says error, repeat, right? You want to know the test is working properly. You want to know you performed this procedure, this test, basically, properly. Is it purple? Is it positive? Did it get decolorized and is now pink and is, in fact, gram negative? So those of you guys in lab, right, whether it be my lab or someone else's lab, right, I've got lots of videos for you guys. This is a tough technique. I'll demo it. We'll do it. You'll get it. It just will take sometimes a little bit of time, right? It's one of those ones where we're being precise, right, and taking your time will pay off in the end. All right, so that's it for right now for gram stain, but as I said, it will never go away. And I think that connect assignment I wanted you guys to do is the animation with questions built into it. Right? So remember too, like if your computer's not playing it or something like that, or you're having computer issues, whether it be internet or anything like that, I'll put the hours up, but they're pretty much like always open, even on Saturday. The open lab upstairs is another place you can go, computer lab, right, to work on stuff. As well as in Building 1, the Hibernia Center is a really good place to go. It's usually nice and quiet, and the student workers are helpful, and it's close to my office, so if you need help, I can run over if you message me. So I actually want to do a separate recording for the next